Thanks everyone for joining in for this special talk on how you can make AI inference efficient with the latest Intel Xeon 6 processors. So, as you are all aware, we released the next generation of Xeon 6 processors sometime last year uh, with uh, with the extremely good specifications, if you ask, right? You could look up to 128p cores, performance cores targeted for AI workloads. And these processors are specifically inbuilt with GPU for accelerating the AI workloads in terms of AMX and in terms of MRDIMS availability. So, how does AMX helps with accelerating the AI workloads? Is that most of the calculations are, as you're all aware, the model calculations are going to be matrix multiplications, and we have AMX operations inbuilt into each and every core of the process to make sure that the multiplications have to happen at a faster rate than just using regular AVX521 instructions. And apart from that innovation, we also have the latest support for MRDIMS, which gives you more than 30% higher memory bandwidth and support a majority of high memory context model sizes. And we are not just talking about hardware specs, but we are also talking about a varied use of softwares that we have enabled from an ecosystem standpoint. So, be it the regular PyTorch user who just wants to load the model and see how it works, or be it the advanced users who wants to serve it on various platforms on an inference scale, we have them all covered. So, and also for people like AI enthusiasts who just want to try the latest and greatest model on their available hardware, we have optimizations upstream directly over to Olama and whatnot. Now, having said that, the entire landscape of AI inferencing, specifically LLM inferencing, is changing nowadays, right? What started off as BERT evolved into Llama, and now we have a slew of mixture of experts, which is competing at the performance levels from a qualitative metric standpoint of frontier models. So we want to make use of the best possible ways, the most efficient ways on how you could run these models at a cost-effective fashion. Now, the components that we are going to be looking in the talk is not something new. We have seen this happen in the past too when it comes to computer vision models. Even with computer vision models, you had to have very big models when it started to get a very decent performance in terms of qualitative metrics. But things change so much that the model size reduced more than 25 times, right? And you could get a very decent performance or even state of the art performance in those smaller models to acquire any specific task. So, threading along those same lines, we are here to talk about three different methods, the way you can make the inference much more plausible and eatable in the enterprise AI setting. So the three main methods that we are proposing again is quantization, mixture of experts models, and also using of distributed inference to support more concurrent users. To start off with quantization, so the latest Xeon 6 processors, like we saw in the first slide, supports bfloat 16, fp 16, and int 8 through native operations. And support for other things like FP8, integer 4 emulations are available from a software emulation standpoint. So, be it GGML models or GPTQ models or AWQ models, all works flawlessly fine with the latest Intel Xeon 6 processors. And all these models, all these optimizations have been upstreamed into these libraries that people tend to commonly use. Be it transformers, VLLM, SGLang, we have all those bases covered. And quantization is quite an interesting topic, I would say, because people typically observe a loss in terms of qualitative metrics when you quantize the model, be it to low precision, or be it, when I say low precision, I'm talking about integer 4, integer 3, integer 2, or FP4, and whatnot, right? People do observe loss in qualitative metrics. And we have a product in-house called Intel Auto Round that alleviates that problem for you. So the chart that you see on the right I could have made it a bit bigger, but the whole idea is the purple ones are the models that have been converted through Intel Auto Round, and those are 4-bit models. And you can see that next to the green ones, which is the bfloat 16 model, the metrics have not been drastically compromised, unlike the 2 smaller or 3 smaller bars on the leftmost, which is like GPTQ and AWQ models. So you do have a method of using a calibration data set along with the quantization so that the model's loss is not so drastic. Now, coming over to mixture of experts, this is from the artificial analysis website, and you can see that you now have 3 open source models which are competing with the frontier models in terms of the intelligence that's available for the public. And the sorry fact is that you would need simply an 8 GPU cluster or an 8 accelerator system just to load the models and try it out. Whereas the actual activation parameters in each of those models are very, very small. So for instance, GPT-OS is 120 billion parameter. You hardly have like 5 billion active parameters. Whereas the model size, it needs at least 80 GB in terms of precision 4 data type, right? And the same thing with Qwen 3. Even though it has 23 billion as a total overall parameter size, you hardly have 20 billion parameters, which just need to meaning you need less compute to process those experts in this model, but you need a large memory bandwidth and memory storage available just to load the model and operate on varied context size for users. And that is where Intel Xeon helps the end users, meaning you could get very, very best performances in terms of latency, be it optimizing for latency or be it optimizing for cost. You can get the best configuration out of the existing servers in your data centers. Now, coming more to the distributed inference standpoint, just to quote what LMSys had said in the collaboration that we did with Intel to optimize these bigger frontier models on latest in Xeon 6, they have said that each NUMA node acts as individual small accelerators in a given system. And in a given system, so 2-socket system, you could have anywhere between 4 to 6 NUMA nodes, meaning you do have 4 to 6 small accelerators, which optimizes the pipeline. So be it a small model where you want to speed up the calculations, you could use it through tensor parallelism. Or if you also want to do high processing, or rather processing individual parts of a model in individual NUMA nodes, that can be achieved through pipeline parallelism. And also, if you want to scale out, scale in, we also got that covered through data parallelism in things like LLMD or Red Hat OpenShift. We do support native Kubernetes so that you don't have to do everything from scratch. So we do have solutions that's available out there right now. Take it out of the box and deploy it straight away. Now, coming on to the next slide, these are few numbers that you could look up on why Xeon is the best CPU. Xeon 6 is the best CPU for AI inference, specifically LLMs. So these 3 charts, the one on the leftmost compare the benchmark numbers against our competitor and show that our 64-core CPUs outperform the competitors' numbers for a 128-core CPU, latest generation combined, right? And the charts on the left and the bottom are for Llama 3 8 billion. However, on the chart on the right, we are looking at the larger model sizes. We're talking about the 500 billion parameter model like DeepSeek R1 or the Qwen 3 235 billion, or even the smaller model sizes, even be it like Llama 3.2 to 3 billion parameters. So you can address your organization's SLAs in terms of you want to optimize it for latencies, or be it optimizing for cost, that can be achieved with the server that you already have in your system. Sockets are individual CPUs that goes into the system, the server.
Okay, number of CPUs basically.
Yes, number of physical CPUs.
Physical CPUs. Yes. Okay, thank you.
Sure. So we have also have an enterprise AI offering that can run generative AI models at scale with the accelerator that we have for people. So think of this as people who are looking for model as a service solutioning. So we could go right to the next page where we have the links available, where you have this entire stack of applications, be it LLM serving, be it model-specific optimizations, be it orchestration layers. Depending upon what type of operating system and the hardware that you want to do with, we have support for all these different components out of the box. And either you could do it on a do-it-yourself basis, or you can go for cloud providers like IBM Cloud or Denver Cloud, or many other providers who would give this solution out of the box for you, for the end customers. So I just want to point out to this page that we have, AI software catalog.intel.com. So all these different solutions that we talked about, that we saw about, are available for free, no licensing fee, no extra pay. You can go ahead, download, and actually try out these models in the existing data center for right away. Next, we're going to see a small demo on how we're going to be serving, how we can do the LLM serving as well as the chatbot on the using RayServe. And the whole idea is that you already have the data pre-processed, load into vector database through CPUs, and you'll be using the same CPU systems just to go ahead and serve the LLM chatbot out of the box. So no additional accelerators employed in this setup. So let me go ahead and play this. So what you see here is that this is a 96 virtual CPU system, meaning 46 actual cores, no accelerators whatsoever added. And the code that you're going to be seeing in the subsequent slides is that just with one line of modification where it says resources per bundle as GPU equals 0. So with that one line, you could just disable the GPU systems that are made available to the system and just run it on the CPUs. Now we're just going to take this code and just run so that the server spawns up. It's going to take some time. And by the time it's done, you're going to see that all these NUMA nodes that's there in the physical server are going to be bound to the deployment that's out there. Now the replica is kind of up and running. Let me see. Right. So now once the replica is kind of up and running, you go to the front end, go to the deployments that you already have, and you confirm that the system is available. You click on the link, and you also can go directly onto the deployment config to double confirm that there is no GPUs and just CPUs allocated to the system. So once you have the system up and running, again, just a visual of showing that all these configurations just running on a CPU. And then you just launch the deployment, the URL that you've done from a deployment, and you see that you're just typing out a question. So this vector database has documents from any scale dump. So you're just taking that dump and just trying to do a chatbot, a smallish chatbot on lots of sorts. So as you can see, it's like pretty straightforward, no additional configuration changes, just one line changes, so that you can get started right away for your AI journey with any scale. And we also actively working with Ray to ensure that you have auto-scaling deployment, enterprise deployment, to make sure that the customers get the best out of the latest Xeon processors and Ray. Thanks all. So a few links if you want to go on, and that is the QR code if you want to go and hit out the software page that we talked about. And this next URL is going to be additional demos, talks that we all have from Intel. Feel free to watch and reach out to us if you have any help. Thanks.